So thank you very much to all the people here, and thanks for having organized this amazing school. And I'm really glad you have invited me here. And I'm also thankful to, and I'm honored to speak after Ian Fairchild. And I thank him to have introduced some of the topics I'm gonna talk about today. So the today's talk is about good practices in Speleothem science from sampling to post-research. And due to the limited time, is mostly based on my experience, but also I will give you some example from the literature. So yeah, what is the problem about? So we guys are really extremely lucky to work in caves, because caves are one of the most spectacular and one of the most unique place on Earth. There are multiple caves on Earth, and are still many caves to be discovered. But as these caves are unique, they are as much unique as delicate and fragile environments. And they are fragile from multiple perspectives. For example, from an ecological point of view, there are ecosystems that lived, and their existence is based on the equilibrium condition of caves. I'm talking about microbial groups, for example, and only our presence in this cave is kind of modifying the equilibrium condition of pH, temperature, and pressure upon which this ecosystem rely. And so we are kind of impacting a cave ecosystem. From the other side, we all know that caves are really fragile from a geological perspective. Crystals are fragile, the cave formation are sometimes very fragile and can be, and they are usually very white, so can be dirty really easily. And also we have to consider that caves, because of the show caves, have an economical implication. And so at times our impact in caves can modify their aesthetics, and so we can have problems from this perspective. And also our activity in caves is possibly one of the most impacting, because we all want here to take the best samples from the cave to the lab and do our science. And when I was preparing this talk, I was really glad to find out this paper from McGregor and my previous fellows in Melbourne. It was published very recently in the International Journal of Speleology. We're gonna see this paper later on, but I was very glad to see that straight in the abstract, they say that conservation of cave environments is a key responsibility for scientists. And I really agree with this statement. So we're gonna see this paper later. But at the same time, when I was preparing this talk, I was curious about how many samples I've collected since the beginning of my PhD in 2013. And honestly, I didn't have a clear idea, so I went through my data and found out that I have collected something around 160 speleothems. It means that there are like 18 per year, and only the half of them were dated, at least bottom and top, and only the 25% of them were analyzed, but I believe it's even less, this number. And also because I've published 8 papers as first author, but 4 of them are about paleoclimate reconstruction, and 4 of them are about speleogenesis, geology, and geomorphology. In general, to me, it takes on average of 20 speleothems to publish a paper, and for paleoclimate reconstruction, it takes 40 speleothems. So number gets huge. So I went in Scopus, and I found out that since 2000, 600 papers having speleothems in the title or keywords were indexed. And so according to my estimation, 12,000 speleothems were sampled in general for general papers about geology and geomorphology, and 24,000 speleothems were sampled for paleoclimate papers. Of course, this could be an overestimation because of several factors, but I think this gives us an idea about the order of magnitude of number of speleothems we are collecting, and something that we have to think about. So when we are doing our job, our ideal workflow is to do some planning, then go to sampling in cave, and this is myself looking for a good speleothems, and then only the good sample goes to science. Here there is Yassin Ibrahim. I don't know if he is in the audience. I didn't ask him the permission for put this picture, but anyway, I hope he is as much happy as in this picture. And then all the samples, those we have used for science, but also those we have not used, goes in that part of our activity that I call here the post-science. And sometimes they are just stored in offices or in deposits or in some museums, as Ian said before. So then the part of our job where we can actually act to minimize cave impact and or valorize caves is in the planning, in my opinion, in the sampling, and also in the post-science. So we're gonna go through this activity in this talk. So there is a point in which we are making plans to accomplish our project, our PhD, our postdoc. So when we are planning a sampling campaign, I first really suggest to ask your colleagues from other institutions if speleothems of a specific time interval are already available from a specific area. And this is within the line of what Ian said in the talk before, because sharing is caring, and we're gonna see this philosophy a little bit later. Of course, if we use samples that were already sampled, we don't have to do some oversampling in caves, basically. At the same time, and this is kind of an idea I'm developing in the last years of my activity, let's say that you are targeting a certain area, and if in that area there are show caves, but also there are wild caves, I suggest to only target for sampling the show caves, leaving wild caves as much pristine as possible. And also be sure that speleothems are not already available at your institution. And this seems a joke, because as Ian said before, a good cataloging is key, but at times this is not well done. So this is the deposit, the old deposit of my previous institution in Bologna. So we thought they were doing some work for refurbish the area, and there were these old boxes here, and they contain all a series of rocks, because of course this is geological department. But I also found many speleothems, like around 20 good-looking speleothems that I was not aware of, and nobody in my department was aware of. And so I'm working now on them. And in this way, I didn't have to go to other caves to do some sampling. So after the sampling, after the planning, of course, we go to the cave to do some sampling. And you may now asking, what is the best sampling approach in order to minimize cave impact? Well, there is not a single answer here, and it depends. It depends from many factors. It depends from many perspectives. It depends, for example, on your aim, of the scope of your research. It depends on the status of your career. If you are a PhD, a postdoc, a professor, or you are retired. It depends on your area of study, if it's remote or if it's easily accessible. But it also depends, unfortunately, on your funding, on the money you have to do your research. But at least I think we can all agree from one single cornerstone, and that it is to do not break still standing stalagmites. I think this will be something that we should all agree here, and this means that we only have to target those speleothems that are already broken. That and so fall apart. That, in my opinion, they are always, you can always find speleothems, broken speleothems in caves. And the reason is because all the unknowns regarding the potential, the scientific potential of a speleothem, of a stalagmite, there is no reason to me to only break a speleothem and take it in the laboratory. To my opinion, it is not necessary if other fallen stalagmites are viable. And also, I think one of the main reasons of doing that, because I think that looking for broken speleothem is the fun part of the job. It's like a treasure hunt, and we have the possibility to be kids again, play a little bit. So sometimes it's really just fun to look for different pieces of broken speleothems in the cave and try to make like a jigsaw puzzle and just having fun while we are doing our job. So we should not forget this. And at times, it's really easy to find broken speleothems, unfortunately, because some caves are vandalized, like in this case in Sardinia, in Italy. Unfortunately, it's very common that you find vandalized caves, possibly because speleothems were sold in the past, as George Veni showed before. But at times, it could not be so easy. So I'm going to give you a little bit of tips here. For example, I specifically target rooms in cave that have marks of collapses. Of course, if there are collapses, it's more easy that you find broken speleothems here and there. And so I usually go in the bottommost part of the caves, because by gravity, of course, the speleothems goes there. And I look around the fallen blocks. And for example, here in this cave in southern Italy, I found this stalagmite here in the right picture, just in between these two blocks. But if you are in a show caves, try to explore the hidden location of the caves. In this way, the removal will not affect the aesthetic of the cave. So you just take the sample, if you have the permission from the local authorities, you just take the sample and the aesthetic beauty of the cave remain unaltered. At the same time, something that I really do when I go looking for speleothems is first, as you can see in the central picture, first look for the base and then look for the relative stalagmite. And I target clean bases, because to me, it means a clean base. It means that that is not covered by mud, is not covered by sediments. To me, it means that it broke recently. So it means that there is a higher probability that the stalagmite is still nearby somehow. And for example, in between, again, these two blocks, I found first this base here, and then I looked around and I found this good looking to me speleothem, just like here in the bottom of the first picture. And I here re-put the sample back to see how it looked originally. But at the same time, if we have a clean base, we can already make some first observation about the quality of the calcite. So if it looks okay for dating, for example, just some preliminary observation, if there are marks of diagenesis and so on. So it can give you like a first impression of the stalagmite. At the same time, what I see I'm saying here is to do not remove anything other than speleothem. This is very important to me. And for example, here in a cave in southern Italy, I found this this accumulation of bones, and at the same time there was this stalagmite here. But the problem was that there are bones. These bones belong to a wild horse that was alive like 100,000 years ago. But anyway, at the bottom of this stalagmite, there were bones attached to the bottom because of the speleothem formation. So although I like this speleothem, I decided to do not remove the stalagmite itself, but so I have contacted archaeologists, and now we are working in a project together. So at the end of the day, our goodwill to try to protect the cave environment brought me to develop a parallel research line with the archaeologists. And also for geological studies, and I mean for geomorphological reconstruction, speleogenetic reconstruction, is very good to work on speleothem rubbles that are fragments of broken speleothems. And for example, in this work by Wade et al. In 2020, they carry on with a project using rubble's ages to deduce climatic information from speleothem growth frequency. Sorry. But also with my fellow in Bologna, Dr. Veronica Chiarini here, and the PhD student Luca Pisani here, we are developing a project called EvolGips that we are only using speleothem rubbles to try to give a detailed speleogenetic reconstruction of northern Italian caves, and like using around 80 speleothem rubbles. And I should have put, I think, this slide in the planning section, but anyway, when you are planning a sampling campaign, ask to local speleologists if they are aware of caves with many broken speleothems, because they really can give you important advice on which cave you can target. And a further step is to instruct locals to recognize the most promising sample, so their advice will become more reliable with time. And I always go in caves with local speleologists, and I suggest to give for them, for example, at their speleo clubs seminars, share your data with them, make them understand what is the importance of the science we are carrying on, and also make them understand that our work, but also their work, is really important for the scientific community. And also, another really a used approach in literature is the screening. With the screening, the idea behind the screening is to only select the most promising sample by using certain strategies. For example, in this work from Frappier in 2008, they carry out a goal-based approach. So they were interested in reconstruct paleo storm, so ancient storm. So they developed a field and laboratory criteria to screen out candidate stalagmites whose characteristic indicate lower sensitivity to stormwater infiltration. So by time and with experience, you can develop your personal strategy to only select those speleothems that are the best according to the project you are conducting. But also an even more conservative approach, in my opinion, is the age screening of fallen stalagmites. This is the paper we have seen at the beginning. So McGregor and colleagues went to caves in Australia and extract little pieces of fallen stalagmites, and they brought the samples to the lab in order to do some age screening, and then eventually they will go back in the same caves to only bring out the speleothems they like more. And there are also scientific benefits with this approach. You can accomplish geological studies without sampling, without extracting the speleothems from the caves, but also you can create a data inventory for future studies. And I think this is one of the best approach if you have the dating lab available at your institution. And at the same time, screening can be done with coring or mini coring. You can go you can just extract basically cores from fallen stalagmites. And in this paper from Speleothem, there are a series of instructions to accomplish the drilling of speleothems at its best. But also you can core still standing stalagmites and accomplish some interesting studies, as in this paper from Croxton et al. In 2016, where they studied the growth frequency variation of stalagmites in southwest Sulawesi by only coring bottom and top of standing stalagmites. At the same time, coring is really a really good approach if you want to study flowstones. And a suggestion is just to cover the whole of the coring after your sampling by some techniques that are described in this paper from Speleothem. And we are already in that phase of our research that I've called post-science. So we end up with a series of speleothems. Some of them were used for our science, some of them were not. But there will be one point in which our deposit will be full of speleothems. And as said Ian before, good cataloging is key for future research, of course, but however, we can also avoid to have endless collection of speleothems in some way if we adopt some approach that we're gonna see now. What we can do here, I think we have three options. So we can bring back the original stalagmite to the cave. We can replicate the removed stalagmite, or we can do something to valorize the stalagmite outside the cave. So bringing back the Speleothem to caves is a Speleothem reinstallation, and one of the most iconic study I think is this one from Wolczak et al. 2015. They basically accomplished paleoclimate reconstruction in unsliced Speleothems because they have used CT scanning. And so they didn't have the necessity to slide the Speleothems. And so after the study, the Speleothem was reinstalled in cave. Of course, this is feasible for unsliced and or repaired stalagmites, but at the same time, we should remember that choosing the dating location is a bit tricky. We cannot really accomplish stable isotope, trace elements, or thin sections analysis. And also it can be expensive or logistically demanding bringing back stalagmites, especially in remote areas. But just consider that there is also this option here. At the same time, we can make some Speleothem replicas. And this is the case if, for whatever reason, we had the necessity to break still standing Speleothems. And for example, from Bazia et al. In 2018, they give you really precise methodology to reconstruct Speleothems by using resin molding and casting. And in this picture here, you can see how basically the replicas and the original Speleothem here on the left and the replica here on the right, they look like the same. So if you are in that case in which you have to break a still standing Speleothem, you must consider at least a replication of the Speleothem you have collected. At the same time, we have options to valorize Speleothems via cultural, didactic, or showcase methods. And this is something that I've developed in one of my last paper here in 2021, published in GeoHeritage. And this is also within the lines of what Ian has said before about donating or cataloging Speleothems in museums. So I'm showing here what is a museumization approach. So how to valorize how the scientific outcomes of our studies for a larger audience. So what we have done here is to just donate half of the slides to a museum in the Castellana Caves museums. Castellana Caves is possibly one of the most important show cave in Italy, in southern Italy, in Apulia, and there is a museum just at the entrance of the cave. So the plan is to donate the samples to that museum, and we have worked in the contents, scientific contents of this panel that is based on one of my papers published in 2020. So, and collaborating with the museum management, we ended up with this nice panel that will be exposed together with the stalagmite, the polished slide of the stalagmite. And all the philosophy behind this is to try to compensate the irreversible damage caused to the cave landscape and to maximize the employment of stalagmites after their removal from their natural environment. But I mean, we are really talking about valorization, about donating at least half of the speleothems to museums, schools, speleo clubs, whatever they can give a more exposition to our speleothems, but at least the showcase should be okay, should be something that is really valorizing our speleothems. This is not the case. This is my new institution in Parma University in Italy. And here in the main corridor, there are multiple showcases showing minerals and rocks. And just at the bottom of this very dark showcase, there are speleothems. There are like here stalagmites, but also stalactites. But this is something I consider a bad showcase. There are no labels, no tags, no info at all. I still don't know where these samples, this specimen come from. And this is how speleothems are exposed in a classic way, where speleothems are only exposed for their aesthetic only. But what I'm trying to say here that we should make a step beyond, a step further, and try to not only show speleothems for their aesthetic beauty, but also because of the potential in science. Indeed, what I was saying is that besides aesthetic, an appropriate showcase allows to maximize the value of the speleothems as scientific and didactic tools, and also it attracts general public to topics related to climate, and we all know how the awareness to the climate is important nowadays. It contributes to the valorization of karst geosites and highlights the importance of cave conservation and protection. And also, especially for small communities, it's something prestigious to have this kind of exposition in their museum or school or whatever. And it could have a financial impact if, for example, a small museum have this specimen, this sample that also have a scientific story to tell. The financial impact is that more visitors will go to the museum. So I think I'm at the end of the talk. I'm just going to give you some take-home messages. So as I said, good planning could reduce cave impact and only target broken speleothems if possible. Consider screening and coring if feasible, and also think about post-science activities. I'm going to give you here a couple of references, but please email me if you want more information or more references. And before giving time to the Q&A time, I want to leave with a question. So as a community, should we encourage speleothem sharing? I mean, should we build up groups, networking that are keen to share those speleothems that have already been analyzed preliminary, but they are not working, they are not actually working because of multiple reasons. I think with the speleothem sharing, oversampling can be avoided, and also, as Ian was saying before, the interconnection with people, with other research group will be key for our growth as scientists, basically. So I'll finish, and thank you very much for listening.